poner para lo de la
Ay,
cosa.
ya se acabó, me están
Guys, keep it down. Shh. Verify that it's. Okay. Paloma, not there. Somewhere else. Sí, ya sabes.
Ay.
Ay, es que esto siempre está en foto.
Okay.
Se la va a darle igual. Que no te pongan rojo.
Can everybody see in the back?
Yes.
Que chequen sus bios.
Is this compounding interest?
Yep.
Okay. Es que yo no.
Okay, so since there is a term test on Monday, and next week is review week, then I will take today to review instead, so that it's basically today is like the Monday of review that you would have done, even though it's not review week yet. And I decided to start reviewing for the stuff that's Paloma. That's why I moved you, so you don't talk to her. I decided to start reviewing first for the material that's going to be on Monday, so it's more useful. I don't think it's useful for me to review right now older material. Okay, so the first section, the section where we're going to start for the term test, is basically 7.3, and then all of chapter 7, then all of chapter 8 that we covered, which was 8.4 to 8.6 or 7 or something, whatever we covered. And then everything that we covered in chapter 10, which was the probability stuff. Okay, so that's the material that's going to be on the term test. Let's start with the first question of the quiz of chapter 7. So you deposit $800 in an account that pays 2.65% interest, compounded continuously. What is the balance after 12 and a half years? So whenever you hear the word compounded continuously, you have to use one of the formulas that I gave you. So there were two.
Daniel Arevalo and Valeria Aje report to Miss Caro's classroom.
There were two equations for compounding interest. Does anybody remember what the two equations were?
One has to do with E, but I'm not sure.
No, one is A equals P E.
A equals P E
RT.
to the power of RT. So this is the equation that we use whenever it says compounded continuously. That means that our interest is recalculated every moment of every second for the duration of the loan or the account balance. So this is one of the equations. Who remembers the other one?
Without the T.
Era en un paréntesis, ¿no?
Yeah.
There was a parenthesis,
Over,
there was like
no?
one.
Over something.
Dividido entre 100, algo así, ¿no?
It was over something.
Remember.
And that thing multiplied by the power.
Era R, uno era R. Que era rate, que era rate.
It was 1 plus R here.
Y luego power
And
arriba.
a P.
There was a T here.
And T.
But if we wanted to see how frequently, so this was the original value. I don't remember what variable they used in the book, but I'll call it P, the principal. Sure, I'll do capital P just so that it's the same. So this P is like the starting amount. The P is the starting amount. The A is the final amount after whatever time. So this was the equation if there was no compounding. This was the equation if there was no compounding. But if you did compound, R divided by N, Tn. So we'll just keep this one. If we don't specify that it's compounding, N is equal to 1. If we compound, then N is equal to the number of times that you compounded. So if it's over like 2 years and we compounded 4 times over those 2 years, then N would be equal to 4. In this case, because it says compounded continuously, we have to use this equation. We cannot use this equation because we wouldn't have a value of N. N would be equal to infinity. So What are the variables for this equation? Well, the P is the principal, the amount that you start with, and that's the $800. A is what you're trying to find, the balance after whatever amount of time, so A is the variable that we're trying to find. E to the power of R, which is your rate. Remember, your rate, you can't put it in terms of the percentage, you have to move the decimal. So my rate is actually 0.0265. 1, 2, yep. And then T is the time that passed, which is 12.5. Right, so here you're just filling out, like once you realize that it says compounded continuously and you have to use this equation, then you just plug in your values. Your principal is here, that's the starting amount. E is just a constant like pi, and then R is your rate. You can't use this number, you have to use it, like move the decimal place 2 spots. So that's your rate, and then 12.5 is the time. I don't have my calculator, so can somebody put this in your calculator and tell me what it gives you? Somebody has a calculator?
No sé.
No pobre.
Okay. 1,114.17.
17?
Yes.
Okay, so the final balance after 12 and a half years is $1,014 with 17 cents. Always, whenever the answer has to do with money, just round to the nearest cent. That means 2 decimal places. That's the nearest cent, 2 decimal places.
Mister, entonces el de arriba, ¿cuándo se usaría?
This one?
La de abajo.
This one.
¿Cuál es la diferencia?
So this one is whenever it says compounding continuously. Do you remember what compounding means?
Sí.
So like, let's say my loan is a duration of 1 year, and my loan is compounded every month. That means that every month we're going to recalculate how much I owe, and that means that's what compounding means. This equation is whenever you specify how many how frequently you compound. This is compounding continuously, like every single instant, and then this one you specify how many times you've compounded. So for example, let's do the same problem, but instead of continuously, let's say that it's over 1 year. It's just over 1 year, and it compounds every month. Then we have to use this equation. I'm still trying to find A, my final balance. The P stays the same, that doesn't change, it's still $800. 1 plus, okay, so my rate is still the same thing, 0.0265 divided by N, the number of compounding terms. Because it's only for 1 year and it's every month, then N is equal to 12, that's the number of times that I compound. And then time, it would just be 1 year. And then N is equal to the number of times that I compound. And so that would be your equation. And this number would be slightly less than this.
Mister, I understand everything, but I don't know how to solve. I have to multiply both of the exponents.
Yeah, so you would multiply the exponents. This would just give you 12. I would actually start, remember your order of operations, PEMDAS. So parentheses first, I have to evaluate whatever's inside here. To evaluate this sum, I have to figure out what this number is. So I evaluate what this number is, and then I add 1 to it, and then whatever that value is, I raise it to this power, and then I multiply by that.
Mister, why you just put 12 months?
Say that again?
Why did you just put 12 months?
Here?
Yes.
Oh, because I changed this problem so that the question says that I'm compounding monthly. And so N is equal to the number of times you
Emilio
compound.
Fimbres, come to the office.
If the loan duration is 1 year and I'm compounding monthly, then I have 12 compounding terms. Okay. I didn't think that people would struggle as much as they did with these ones. I thought that we covered it in class a lot, but yeah, a lot of people struggled with this part.
Yeah.
So finding the inverse function, y is equal to log base 8 of x. Okay, does anybody remember there were two steps whenever we're trying to find the inverse function? There were two steps.
Change x and y.
Change x and y, that's the first step. So the first thing you need to do is just change x and y. Okay, so we're done with the first step. That's the easiest step in the world. Literally just swap the two variables. If I'm asking you to find the inverse of the function. Once you do that, then you have to solve for y. That's the second step, solving for y. And this is where a lot of people struggle. A lot of people didn't remember that if we have log base 8 of y, my y is kind of stuck inside my log function, and I have to get it out of the log function. The only way that I can get it out of the log function is if I apply the inverse function to both sides of the equation. So try to think of it this way. X equals square root of y. If I ask you to solve your y, what is the issue here? The issue is that the y is stuck inside my square root function, right?
Yeah.
It's stuck inside my square root function, and I want to get it out of my square root function. How do I do that? Well, what is the inverse of a square root? What's the opposite of a square root? You square it, right? So if I square both sides of the equation, my square root and my square, since they are inverse functions, they're going to cancel each other out, and I'm going to free my y. So this is y, and then because I'm doing the same thing to the left and to the right, now I get that y is equal to x squared. Right? Everybody knows how to do this, but they don't know why they have to do it, right? And so the reason that you apply this squared function is because the squared is the inverse of the square root, and you're trying to get rid of the square root. Does that make sense?
Yeah. Mister,
Yes.
Wouldn't it be putting an 8? I don't remember how, but you put an 8 on both sides.
Right.
And you cancel out the log 8.
Right. So in the same way that we had to use the inverse function of the square root to get rid of the square root, we have to use the inverse function of log base 8 to get rid of the log base 8. What is the inverse function of log base 8? Is 8 to the power of that variable, right? 8 to the power of
Log
something, right? So to get rid of this log base 8, I have to put an 8 as a base, and then my exponents are these two things. So I'll do 8 to the power of x is equal to 8 to the power of log base 8 of y. Okay? The inverse function is an 8 with this thing as its exponent. Now, what's going to happen? 8 to the power of log base 8 is just gonna cancel everything, and it's just going to give me whatever I had inside the log. It's just going to give me y is equal to 8 to the x. This I didn't change. And so this 8 to the power of log base 8, they just cancel each other out, and I'm left with the y. Not in the exponent anymore, just regular y. And that's how I cancel the log base 8. I have to do 8 to the power of that. Similarly, if I had x is equal, let's say, to 13 to the power of y.
Mister, I have a question.
Yes.
It's why does the question say y is equal to log base 8 of x, but the answer also says y is equal to 8 to the x?
These functions, you always solve for y. And so this y equals 8 to the x is a function, right? This is just a regular function.
Okay.
And this is another regular function, y equals log base 8 of x. And so these two functions are inverses of each other. And we covered, like back then, we covered like what it meant to be the inverse of each other. But yeah, they're just inverses of each other. And so the question was just asking, like, find the inverse function. These are just two functions, and they happen to be inverses of each other. Okay, similarly, if I had something like this and I wanted to solve for y, what's my problem here?
The y is to
Que
the
el y no
log.
está solo.
Y is stuck in the exponent, and I want to get rid of it. How do I get rid of it? Well, I have a y in the exponent, I have a 13 as a base. So if I have this function, 13 to the power of y, what is the inverse function of this 13 to the power of y?
Log 13.
Log base 13. So if I apply, remember, whatever I do to the left, I do to the right. That's just a rule in algebra. If I do log base 13 on both sides, I'll get log base 13 of x is equal to log base 13 of 13 to the power of y, and these cancel out each other, and I just get y here. So y is equal to log base 13 of x. And that's how I got rid of my y in the exponent. Okay. Y equals log 3 x minus 5. Okay. Find the inverse function of this. Does anybody want to try? I don't have my phone, so I can't call on people. First step, what do we have to do?
3.
Can't no. Change x and y.
Change x and y. X equals log base 3 of y minus 5. Okay. What's my next step?
We put that to the power of 3.
Other way.
Yes, like
3 to
that.
the power of that.
Okay, yeah.
Right? Because I have a log base 3 and my y minus 5 is stuck inside my log base 3, I want to get rid of my log base 3. How do I get rid of my log base 3? I apply 3 to the power of this, and it's going to cancel out. So again, whatever I do to the left, I have to do to the right. I can't just do it to one side. Andrea, wake up. So I'll do 3 to the power of x, that's on this side, is equal to 3 to the power of log base 3 of y minus 5. And what happens here? 3 to the power of log base 3 cancels everything out, and I'm just left with whatever was inside my log, which is y minus 5 is equal to 3 to the power of x. Now, I still have to solve for y. I haven't solved for y because y is not by itself.
You add 5 on both sides.
So I add 5 up on both sides. Y is equal to 3x plus 5. I switched the order, but that's what you get.
Monsieur,
So this is the inverse function of this. Yes.
I had a problem with the ones on the bottom where it says approximating expression.
Right.
So what I did, I imported log base 4. Ya ni me acuerdo qué hice, pero
Okay.
no le entendí y terminé sacando uno de 2 en uno y en el otro saqué 0 de 2.
Yep. So we covered this in class. It was in one of my slides. And basically what you have to do is rewrite these logs in terms of these logs so you could approximate. So this would be like if you didn't have your calculator and you had you knew these logs. So you write these logs in terms of this, and then you just approximate using these values. So what a lot of people did was just plug this into their calculator and put the value in. That's not what I wanted you to do. So what you had to do was use properties of logs, log of 1/3. So use properties of logs to rewrite this in terms of these two things, and then you can approximate. So what do I mean? So log of 1/3 I can rewrite it. I need basically log of 4 and log of 12. That's what I need. Somehow I have to get to log of 4 and log of 12. And so this 1/3, that's equal to log of 4/12, right? 1/3 is the same thing as 4 divided by 12.
Eso sería mi respuesta.
1 second, not yet. I said I have to get log of 4 and log of 12. I currently don't have log of 4 and I have log of 4 divided by 12. That's completely different. Now, what properties of logs can I use to kind of split this this division up?
Quotient.
The quotient property. What does the quotient property of logs tell us?
That it's log 4 plus log 12.
No, when it's division, it's minus.
Minus.
So log 4 minus
Log
log 12. So this is equal to this just because of standard algebra, right? 1/3 is the same thing as 4 divided by 12. And by the quotient property of logs, if I have log of 4 divided by 12, that's the same thing as log of 4 minus log of 12.
Yep.
And now I can replace what's log of 4? Well, it's right here. 0.602 minus log of 12, 1.079, and whatever this answer is.
Seems so easy now.
Yep. And we did it in class. That was the most frustrating part. We did it in class. And so it should have been on your notes, and this was a quiz, and you had your notes.
What about log 64?
Right. So how do I write log 64 in terms of log of 12 and log of 4? Yes.
You need to divide 64.
What do you mean?
Wait, no.
64 is the multiplication between 4 and 12.
No, 4 and 12 is not equal to 64.
You need
4
to
and
make
12 is
it
equal to 48.
You need to make it divide.
Bro, yeah.
Wait.
No cabe, ni modo.
Lo haces.
Wait, don't do it.
64. How do I write 64 in terms of 4 and 12?
4 squared. No, 4 to the 4. 4 to the 4.
16.
It's 4. 4
4 cubed. 4 cubed. 4 times 4 is 16. Times 4 is 64. And so 64 is the same thing
You can 4 to the third.
as 4 cubed, 4 to the third. Right? The 64 and 4 cubed is the same thing. And then how can I rewrite, what property of logs can I use to rewrite this?
Product.
Ooh.
Product? No.
The power property of logs tells me that if I have something to the power of something, I can grab this exponent and put it in the front. And so this is equal to 3 times log of 4. And then I can just replace log of 4. So 3 times 0.602. And whatever that is, that's your answer.
What about 12? You can't use 12, right?
No, you just don't use it.
You just don't use it. You don't have to use it. You just use that and that. Makes sense? So,
Esto está bien fácil, güey.
yeah.
Easy.
But you know what happens? You know what I think happens is that you come to class, you pay attention, whatever, and then you don't study. And if you don't do it yourself, if you just see me do it in class and don't practice it yourself, you forget how to do it.
That's so true.
That's like the classic, like if you don't do it yourself, you make these kinds of mistakes and you get confused because you never practice it yourself. It's really different, really different to see me do it in class and to understand. That's easy. Just following what I'm doing, this is really easy. But actually you doing it without my help is hard. So you have to practice that. So if you get it in class, if it seems easy in class and then when the test comes, you get it all wrong, that means you didn't practice yourself. So start practicing yourself if you want to get better grades. But that's the problem.
So we need more homework. That's like.
No, he's right. Yeah, he's right. No, tienes razón.
La tarea la copian todos de todas maneras.
No, I don't
I don't have to assign homework for you to go to the book. You have the book and just do problems.
Bueno, pero eso.
No, yo digo que deje tarea porque ahorita.
Dice que
It's way too late for that.
Traigo baja calificación, mister.
Okay, so log
Tengo que sacar un 100 casi en el tiempo.
log 10
Tan mal vas
x
que
to the 3.
tan mal.
So expand the expression. Again, we did this in class. Expanding the expression just means use all of the properties of logs to kind of simplify the log as much as possible and get like some log plus some log minus some log, whatever. So who sees what is the first properties of logs that I can use to start expanding this?
Power.
The power. We have to use power first because this exponent doesn't apply to the 10. This is 10 times x to the power of 3. I can't move this power of 3 yet because this power of 3 doesn't apply to this 10. So I'll use the power property first, split it up. Log of 10 plus the power property, the product property tells me that if I have something multiplying something else, I can do log of 10 plus log of x to the third. And now I can use the exponent property. 3 log of x plus log of 10. Now, some people just wrote this as a 1 because since I'm not specifying the base, when I don't specify the base, what's the base?
10.
It's 10. And log base 10 of 10 is 1. So some people just said 1 plus 3 log of x. Either one of these was fine.
Okay.
Okay,
Qué bueno que
Yep.
no entendí. Qué bueno que me lo entendí.
that's it.
A ver, la siguiente.
Log base 2 of 2 over 5.
So for the quotient.
Quotient property, that tells me that I'll do log of 2 minus log of 5. Log base 2 of 2 minus log base 2 of 5. Again, log base 2 of 2 is just 1. So I can get 1 minus log base 2 of 5. Some people left it like this, that was fine. Some people left it like this, that was fine. Some people plugged this into their calculator and did 1 minus that thing and gave me whatever answer that is. That's also fine.
Okay.
Any of these. Literally, that's all you have to do. Apply the quotient property. Okay, this was the last, I won't go over the extra credit, but the last kind of problem that we saw in this quiz, that we saw in this quiz was the equations. So, 5x minus 4 is equal to 5, 1 second, 3x minus. Guys, it's recorded. Everything you say is going to show up in the video. Okay, so in the book they mention a property that says if I have the same base on both sides of the equation, I can just make a new equation just with the exponents and make the exponents equal. And that makes sense. Remember that we covered this in class. I said something like if I have 2 to the power of 3 is equal to 2 to the power of x, what's the value of x?
3.
You don't have to really do anything because you know that 2 to the power of 3 is equal to 2 to the power of x. Well, everything is exactly the same except these two things. So I know if this is true, then 3 has to be equal to x, right? We can make it more complicated. We can say 3 is equal to 2x minus 10, right? Well, what's the equality here? I know that it's 2 to the power of 3 is equal to 2 to the power of 2x minus 10. So if this is true, then what also has to be true is that 3 is equal to 2x minus 10. That has to be true if this is true. Does that make sense to everybody?
Yes.
So if this is true, then I can just solve for x here, which is easier. Move this over here, I get 13 is equal to 2x, and I get x is equal to 13 divided by 2. Right? This is the rule that we want to apply. Now, for problem 8, that's very simple because I already have the same base. So if I have 5 to some power is equal to 5 to some other power, then these two powers have to be equal because I just have 5 to some power equals 5 to another thing. So if this is true, then x minus 4 has to be equal to 3x minus 6. This has to be true. And so now I just solve for x. Move this over here as a minus, I get 2x. Move this over here as a plus, I get positive 2. And I get x is equal to 1. And I'm done. That's it.
But don't you have to plug it in too? Plug it in number 10, I remember you had to plug it in.
In number 10, you remember you have to plug it in. I don't remember if you have to plug it in. So there are some cases where you do have to plug in when you divide by a variable, and then when you take the square root. I don't think you have to plug it in this case. No. Now, here if you do 4 to the power. So there are some cases when with the log that you have to check that you don't get a negative number because logs are undefined for negative values. Like if you put like a 2, like x equals 2 here, you would get log base 4 of 2 minus 5, which is negative 3, and that doesn't make sense. You get an undefined answer. Like the log function does not accept negative numbers. So in that case, yes, but in this case, I don't believe so. In this case, you. Okay, so what is over here 4 to the power of 2x minus 5 is equal to 64 to the power of 3. Right. Can you, sorry, can you 2x minus 5 is equal to 3x? Can you do this?
No.
Why not?
Porque no es el mismo base.
You don't have the same base, so you can't make this like equality because you don't have the same base. It only works if we have the same base. So we have to do something so that we do have the same base, so that we can do this.
No se puede hacer 4 al 3, dice, ¿verdad?
Right, so 64, how can I write 64 but with a base of 4 instead? So 64, remember,
For cube.
is equal to 4 to the cube. So I'm going to rewrite the 64 as 4 to the cube, right? 4 cubed to the power of 3x. I just rewrote the 64 as 4 cubed, and it's still to the power of 3x. Everybody agree that I haven't really changed anything?
No.
Yes.
After I've done this, what do I have to do? What property of exponents do I have to use so that I can simplify these? Power of a power. Power of a power tells me that if I have two powers like this, I can multiply them together, and I can just rewrite it as 4 to the power of 3 times 3x, which is 9x. So this whole thing, like this thing, is equal to this thing. And now I have 4 to the power of 2x minus 5 is equal to 4 to the power of 9x. Now I have the same base. Now I can use that rule. So I get 2x minus 5 is equal to 9x. Right? Now I just have a simple linear equation. I can solve for x. 2 to this side, I get 7x is equal to negative 5. X is equal to negative 5 divided by 7. That's it. It seems so easy. It seems so easy when I did it in class, but if you don't do it correctly in the quiz, that means you're not practicing. And I've been saying this the whole year. A lot of people, even last week, I told them like, oh, just like look at the book online, and they're like, where do I even find that? Like even last week, the whole year, they did not look at the book a single time. So that tells me that you're not practicing. If you haven't looked at the book ever, you're not practicing. Just looking at my slides and just paying attention in class, for some people is enough. For other people, it's not enough. You have to practice. So by now, you should know if that's enough for you, and if you want to get a better grade, you need to practice. That's what's missing. If you understand it here and you still get it wrong in the quiz, that's what's missing. You need to practice. Okay, last one. Doesn't the class end? Oh, it ends at 40?
40.
Okay. So last one.
Yeah.
8 log base 4 x minus 5 is equal to 24. Okay, who wants to have a crack at this?
Me acuerdo haberlo hecho.
Yeah.
So, listen.
No.
So divide 8 by both sides.
Divide 8 on both sides. You're basically, remember when we were trying to solve for, like, whenever we had a square root? The first thing we had to do is isolate the square root, right? So that we could apply the inverse function. So before we can apply the inverse function of the log function, we have to isolate the log before we can do that. So to isolate the log function, we divide both sides by 8. And we'll get
log base 4 equals 3.
And then put 4 as a
okay. Now I have to get, remember, I'm trying to solve for x, but it's stuck inside my log base 4. How do I get it unstuck?
So you raise it to the power. So you put that as your exponent. You put 4.
Right. You do 4 to the power of both of these sides, right? So I do 4 to the power of log base 4 of x minus 5 is equal to 4 to the power of 3. Remember, whatever you do to the left, you do to the right.
So
some people got this, but then they didn't do this, they didn't do the other.
69!
They cancel out.
And then they cancel out, and you get x minus 5 is equal to 64, and then x is equal to 69.
Esa fue
What?
I didn't make this problem.
This
is a book.
Equal to what?
Entró en el libro de algo.
I don't know what's funny, I don't get it.
Ahora que tenga la grabación.